So today we have a Ryobi Airstrike P320. We have a good pack in here, and this one has the issue that nothing happens, like no power, no light, so it will not operate. So the first thing I'm going to do is take this bottom section off, the actual magazine. Some of these are already taken loose, but the rest of these I'm just going to go through and take a loose. So this T10 Torx. And that is ugly. Okay, this one's very interesting because somebody's done had a go at it and tried to take the switch here that is very low current rated, I think a 1/2 of an amp rating, and they have actually tried to tie this in and use it to control the motor. Wow. Hey, we got one we can play with, just test it with, take it apart, see how it works. You know, just experience. When you're looking at something and it has 20 gauge or 22 gauge wire, and in particular if it's not a fiberglass TGGT or a TFE Teflon, very high temp, very high current rated wire. These are just basic 22 gauge wire, just meant to be a signal to a board, and that is all that switch was really designed for. I don't hear it clicking either, so it's probably fried. Hey, still an interesting look inside. So let's just see how bad this one is. We definitely got some wires here chopped off. Got some wires chopped off here. A wire chopped off here. I haven't worked on the Airstrike in quite some time, but I have actually worked on some over the last 5 or 6 years. And a lot of times it'll be a board up here in the handle that has a thermal fuse and some resistors. And a lot of times that thermal fuse will open up. And apparently was the case here. Who knows really, but it looks like apparently this was the case because this is where the thermal fuse would be across. So they decided that they would let this switch take all the load where that thermal switch would be, which unfortunately, that's really what this is for. So they put all the load that this 16 amp micro switch is meant to handle going across these little bitty, I would say 22, 24 gauge wire here. Basically this is like ribbon cable. I mean, it's very, very fine. And of course this little 1/2 amp or 1 amp rated switch that was just a signal back to the CPU, right? It was just coming back one of these here. So yeah, they boxed this one up pretty good. It is FUBAR. Alright, so back now with these wires just cut out and the jumper put in place for testing. Because as we see here, they also ran a black wire, which is way too small for the motor load. It's starting to melt. But they run the black wire from the battery terminal all the way to where the heavier gauge white, and I believe, yeah, that is actually a heavier gauge, a higher temperature coating wire. So it's meant to handle a higher current. So what they have done is bypass where the MOSFETs on the board. It looks like to me the MOSFETs, they control the power to the negative side. So they have basically bypassed the board where it controls it. There's a reed switch board that goes on here typically. And I just realized that's what they cut off here too. It's not there. Maybe this wire still lasts long just for testing. So with that bypassed, will the motor actually run? And it does. But we see that we do have a disconnect here. So I'm going to take the battery loose. I'm just going to take these 4 torques here out. These are torque T20. We'll take these T20s out. We'll be right back. I put that back around the tube here. So we see how our pitman arm of the motor works like any piston or crank. This piston just goes back and forth inside of the cylinder wall. So the motor turns and builds up that pressure and gets released out. So we just got to see why the striker isn't moving. This is also a T10 screw. It's actually a taper head, and the little knob, adjust knob, comes off, and this just falls over. That's how you adjust your depth or your charge there, how hard it hits. And this is actually left-hand threads, and this tube will come off like so. So it is a very, very strong magnet that holds the piston back to the start or home position there. Of course, that would typically stay. There you go. Unbelievably, the striker rod itself is in really good shape. I don't know how much use this tool had before it was destroyed, but very, very strong magnet up here that always sucks it back up as it rotates back, and without the pressure going in, it just goes right to where it needs to be. So that's kind of neat. We do see our ports around here, I guess exhaust ports, which is probably tuned or calibrated pretty well. I'm going to clean them, make sure none of that's clogged up, as well as these on the side here, the main cylinder housing. Just make sure all the seals are good and the ports are free, and we'll put it back together. So apparently turning this dial will rotate this port. You can see that. Rotate this port here in relation to this top plate. That in turn, you can see like that direction going in, right? I guess through here, directed inward through there. And this has been adjusted accordingly, and it should have enough air pressure to push this down, dependent on how far they let you turn the dial for the ports here. Pretty snazzy. I think I'm actually gonna I've taken this little washer off. I'm just going to take the pin out. Okay, so at this point, I don't believe this actually slid out of this. I just wanted to take this connecting rod loose and just look at it. I believe that was just a bumper, and it just rode right there over those ports. Maybe a bumper for the piston and the cylinder, maybe. Alright, got the pin back in the piston. Little protection, little wear pad there to keep the metal pin from backing out and rub it against the cylinder wall here. I believe that just slides down. The tube just slides down like so. Line up roll pin here and here. Yep, there we go. I think that's it. Let's put it back together. And just to clarify, put it back together meant put one screw in here and one screw in here and just leave this on here. And we'll try it out. Leave that out for now. It's definitely pulling and sucking. So now I'm just going to take them 2 screws out and take the tube back out, and I'm going to lube this up and put it back in. Got this apart. Of course, the battery's taken out. like so. So that is our little piston ring there, our little internal piston ring. So this is definitely a 2-piston operation. I'm going to put some PTFE type super lube on it. So synthetic lube. Of course, synthetic lubes won't let the O-ring swell like petroleum base will. Just make sure that our piston ring does go in. Oh, it's good and solid. Man, that is a strong magnet. Great day. Okay, back now. I'm just going to back this off of the, I had it screwed down all the way. I'm just going to back off somewhere in the middle. Make sure this arm's out of the way. Plus to plus, minus to minus. Still got it jumped out here. Let's give it a shot. It worked good. Look at that, the mechanism works great. Just need some cleaning up, lubing up. They have just destroyed some of the electrical parts. And could we make this work by just putting another switch on here and properly getting the signal back to the board? Maybe another day. But I think that's far enough on this video. If you are interested in the airstrike repairs, I may also look into one that does have the blinking light, which is probably what this one started off being, to be honest with you. Sometimes it blows that thermal fuse, and sometimes it goes to the point where you know, we don't know exactly what causes it. It's something in the board, right? You're making sure you're not, the little magazine's not out of staples and it's still flashing yellow LED lights, then it tells you to send it in for service. So there's a board malfunction or a tool malfunction. So hope you like this look inside of this airstrike. Please like, share, and subscribe. Thanks for watching.